back again. Let's talk about antibodies this time. So the first slide shows basic antibody structure. So a couple of things to note. FC just stands for fragment, C stands for constant region. So what you need to remember is that this piece of this molecule is constant. Constant, let's say, for all antibodies of class. And we will go through the 5 classes shortly. And so I'll come back to that and talk about it again. So that's the stem portion. This piece. So there's the stem. And here are the 2 arms, which are the antibody binding region. So there's a hinge region that allows for movement of the arm. So you might think of the stem as being anchored, and then the arms can wave around and bend and move at this hinge joint on both sides. These are polypeptide chains drawn in 2 dimensions, just flattened out, but they're a globular protein, and at the end is the antigen binding site. So the way I've been drawing these before is I was doing something like this, which is what we basically have here in green, and then I was putting a little shape at the end. That's the antigen binding site. So the point is that it's at the end of the arms, and it's representing a very specific 3-dimensional shape. Should also point out that Ig stands for immunoglobulin. So these are globular proteins made by plasma cells circulating in the blood. So the heavy chain and the light chain just refers to the size of the polypeptide. And they're held together by special linkages that we don't need to talk about in this class. But there are 5 classes of these antibodies that we'll go through in turn and just introduce you to them. Before we do that, though, let's take a look at some general features of antibodies in general. So they do quite a variety of functions. So this you should kind of follow along, and it should make sense as we go through it. So one function of antibodies is that they basically serve as the antigen receptor. So what we had drawn before for the B cell receptor was essentially an antibody that was stuck with the stem to the cell membrane. And it had the little arms at the end, right? They could bind different antigens. And this is a B cell as drawn. So antibodies can act as those little antigen receptors. And then we can do the plasma cell, memory cell, that sort of story that we just did. So that should be familiar. Antibodies can also bind to the virus. They can bind to the bacteria and act as opsonins. And the process of opsonization is coating the bacteria or the virus or the antigen with the antibodies. So the process of coating this with antibodies is opsonization. And in some sense, it makes the antigen tasty, if you will, for the macrophage. So we have increased or enhanced phagocytosis. basically the macrophage is able to grab the stem of the antibody, get a grip on it, and endocytose it. The antibodies can also cause clumping, which is what we saw with the blood cell typing. Different antibodies bind to different antigens, and they can cross-link antigens, can form clumps, and that can also be endocytosed or phagocytosed. Antibodies can directly bind to these little bacterial toxins. The little red dots are toxins, little chemicals. An antibody can bind to those and inactivate them. Antibodies are also involved with activating natural killer cells, eosinophils. I'm not going to spend much time I won't spend any time talking about this at all. So I'll just put a little negative sign for no real emphasis on that function of antibodies. On number 5, here is an antibody. We will talk about this step again with anaphylaxis, but there is the Ig molecule, and in this case it's an IgE that we'll come to, that is attached to the cell surface and acts as an antigen receptor. Ag receptor on basophils. Boy, I'm writing pretty small. Basophils and mast cells. Probably too small. You may have to magnify that. We'll come back to it. And antibodies can also assist with this complement activation. So just some general functions of antibodies. So you should be able to name or describe a couple of those. Next slide is our tour through the 5 classes of antibodies. So the 5 classes, MAJ. They're not in any particular order. That MAJ is just an acronym for remembering the 5 different classes. So we have IgM, IgA, etc. IgM, that's too bold, IgA, etc. So this slide shows 3 different arrangements. So Ig, D, E, and G all just form monomers, just a single antibody as we've drawn them. IgA is a dimer. There are 2 of them that are stuck stem to stem. And the antigen binding sites are out at the end. And IgM is a pentamer, where there are 5 IgMs all stuck together, stem to stem, forming sort of a pentagon type shape arrangement. So one thing to remember is that all 5 classes of antibodies are produced by a single plasma cell. So we talked about the activation of plasma cells and how they make antibodies. Well, the plasma cell will make all 5 of these antibodies, and it will do what's referred to as class switching. It'll switch from making one class of antibodies to another class of antibodies. The important thing to remember is that all of the antibodies that are produced by that B cell have the same antigen binding site. They will all bind to the same antigen. So for example, if we were staying with the shape, let's say we have little circles or little half circles at the end of these antibodies, the IgD, IgE, and IgG. Here with IgA, we still have the same shape. So they're all still coming out of the same B cell, and then these as well. So that one activated plasma cell is producing all 5 classes of these antibodies at different times, but they all have the same antigen receptor, but they have different stems to them. So it's the stem that makes them different, not the antigen binding site. Okay, next slide. We take our tour through the 5 classes. IgG are the most common in the blood, circulating in the plasma. About 75% of all antibodies are of this class, IgG. And this class is able to cross the placenta during pregnancy, in utero, go into the fetal circulation, and give the baby a fighting chance when it's born against the opportunistic pathogens that it has never seen before. So it receives antibodies from mom, give it some passive, naturally acquired immunity for about the first 4 months. And then the baby is, the infant is starting to rely on its own immune system for survival. IgG. IgM is the pentamer. And this was the first of the 5 classes. This isn't terribly important, but if you go back to those images that we saw in the last lecture for the primary and secondary immune response, the first bump is IgM. I think that's shown on one of those figures. Not a big deal. I'm not going to make put a lot of emphasis on that. This also is the antibody that was present in the blood when we did our blood typing. So when we were talking about anti-A antibodies or anti-B antibodies, those are IgM. Again, there are probably more important concepts to remember than that. IgA is sometimes referred to as a secreted antibody. So this class of antibodies shows up in the saliva, tears, the intestinal and bronchial mucus, and in breast milk, which breastfed babies are healthier babies. They receive antibodies from mom. Secreted antibodies. And IgD, this is the class of antibody that form the antigen receptor on the B cells. So it acts as the B cell antigen receptor. The antibodies that are essentially made in the B cell don't get released into the plasma, they stay attached at the surface. So those are the IgDs. Again, a note to remember that all 5 classes of antibodies have the same antigen receptor, but different stems. And finally, IgE. And IgE is important for a number of reasons. So let's put a star by IgE. Things to remember is that it's involved in severe acute allergic reactions. So this is our lead up to anaphylaxis. So here's our immune response. So first exposure to the antigen. This equals our primary immune response. First exposure. Okay, the B cell gets activated and makes all 5 classes of antibodies. So this was our activation stage. The B cell receptors bind antigen, B cells, plasma cells, and then they make the IgE antibodies. And those IgE antibodies, when they're released, circulate in the blood and they attach to the surface of the mast cell. Mast cell and basophils. But we'll just emphasize the mast cells for right now. So they're stuck on the surface of the mast cell and then they act as an antigen receptor. No problem, nothing's going on. We've just made IgEs to a particular antigen and those antibodies are now stuck to the surface of the mast cell. Okay? On second exposure to the same antigen, we're going to go over this in the next lecture because I have a whole section on anaphylaxis, but this is sort of the introduction to it. Second exposure to the same antigen. The antigen binds now to the IgE that's on the mast cells. In addition to B cells, the antigen, it'll find the IgE on the mast cells, bind to those, and that stimulates the mast cells to release histamine. And then histamine causes the allergic response of anaphylaxis. And that's what I really want you to understand and appreciate. It can be a life-threatening condition. So that will be our next lecture on anaphylaxis. So look forward to that and see you then. Bye.